Welcome to Azure Application Gateway. Welcome everyone. Today we're going to dive deep into Azure Application Gateway configuration. This is one of the most powerful and flexible load balancing solutions in Azure, and I'm excited to show you how to configure it from the ground up. Please consider subscribing to the channel. I produce videos daily going over Azure, AWS, and GCP. Hit the bell icon to get notified when a new video gets released. Application Gateway is a Layer 7 HTTP/HTTPS load balancer that provides application delivery controller capabilities. Think of it as your intelligent traffic cop that not only distributes load but also provides security, SSL termination, and advanced routing capabilities. Looking at what you'll learn today, we start with backend pool configuration, where you'll understand different pool types and strategies for organizing your servers. Then we move to health probe setup, which is critical for ensuring high availability by only routing traffic to healthy servers. We'll cover listener configuration for both HTTP and HTTPS scenarios, including complex multi-site setups. Routing rules are where the magic happens. We'll explore basic, path-based, and advanced routing patterns. HTTP settings optimization ensures your application gateway communicates efficiently with backend servers. TLS/SSL configuration covers modern security practices and certificate management. Finally, we'll explore rewrite sets for advanced traffic manipulation and comprehensive testing strategies to ensure your configuration is production ready. Configuration flow overview. Before we jump into commands, let me explain this configuration flow diagram. This is absolutely crucial because application gateway components have strict dependencies. For example, you can't create routing rules without listeners, and you can't create HTTPS listeners without SSL certificates. We start with the foundation: Azure CLI login, resource group creation, virtual network setup, public IP creation, and the base application gateway creation. These are your prerequisites that everything else builds upon. Then we enter the main configuration phase with 7 key components. Backend pools define where traffic goes. Health probes ensure those destinations are healthy. HTTP settings control how the gateway communicates with backends. SSL certificates provide security. Listeners determine how the gateway accepts incoming traffic. Routing rules connect listeners to backend pools. And rewrite sets provide advanced traffic manipulation capabilities. Notice how everything flows into testing and validation, then finally production deployment. This systematic approach prevents configuration errors and ensures a smooth deployment process. Each colored section represents a different phase, and you can see some steps can be done in parallel while others must be sequential. This diagram will be your roadmap throughout our configuration journey. Command by command prerequisites setup. Now let's walk through each command in detail. First, AZ login authenticates you with Azure. This opens a browser window where you'll sign in with your Azure credentials. Always ensure you're using the correct account. Next, AZ account set subscription. Your subscription ID is critical. Replace your subscription ID with your actual subscription ID. You can find this in the Azure portal or by running AZ account list. Working in the wrong subscription is a common mistake that can cause confusion. The AZ group create command creates our resource group named RG-Application Gateway-Prod-East US in the East US location. I use this naming convention to immediately identify the purpose, application gateway, environment, production, and region, East US. This makes resource management much easier. The AZ network vnet create command is doing several things at once. It creates a virtual network with address space 10.0.0.0/16, which gives us 65,536 IP addresses. It also creates the first subnet-application gateway with 10.0.1.0/24. Providing 256 addresses specifically for our application gateway. The AZ network vnet subnet create command adds our backend subnet with 10.0.2.0/24. This separation is crucial. Application Gateway requires its own dedicated subnet and cannot share it with other resources. Finally, AZ Network Public IP creates a static standard SKU public IP. The static allocation is required for Application Gateway version 2, and standard SKU provides better performance and security features than basic SKU. This AZ Network Application Gateway create command is complex, so let me break down every parameter for you. We'll start with the parameters. Name sets are gateway name following the same naming convention. Resource group and location specify where to create the resource. VNet name and subnet specify the network location. Remember, the subnet must be dedicated to Application Gateway only. Public IP address, with the value pip-app gateway-prod, associates our static public IP with the gateway. This becomes your internet-facing address. HTTP settings cookie-based affinity, set to disabled, means requests from the same client can go to different backend servers. We'll configure sticky sessions later if needed. HTTP settings port 80 and HTTP settings protocol HTTP set the default backend communication to HTTP on port 80. We'll create additional HTTP settings for different backends. Frontend port 80 creates the initial frontend port for HTTP traffic. SKU standard _v2 is crucial. v2 provides autoscaling, zone redundancy, and better performance. Never use v1 for new deployments. Min capacity 2 ensures high availability with at least 2 instances running. Max capacity 10 allows scaling up to 10 instances during traffic spikes. This command takes 10 to 15 minutes to complete as Azure provisions the application gateway infrastructure across availability zones. Backend pool architecture strategy. This diagram shows our backend pool organization strategy. I always recommend organizing pools by function rather than just throwing all servers into one pool. The web servers pool, green, contains our main application servers at 10.0.2.10 to 12. These handle user web requests and might need session affinity for shopping carts or user sessions. The API servers pool, orange, at 10.0.2.20 to 21 handles API requests. These are typically stateless and might need longer timeouts for complex operations. The external services pool, purple, demonstrates using FQDNs for services outside your virtual network. Application Gateway resolves these DNS names and can route to external APIs or partner services. This separation provides several benefits: granular health monitoring per service type, different scaling policies, separate HTTP settings for different timeout requirements, and better security isolation. You can also integrate virtual machine scale sets which automatically add and remove instances from pools as they scale. This is perfect for auto-scaling web applications where server count changes based on demand. Backend pool creation commands explained. Let me walk through each backend pool creation command. The first AZ Network Application Gateway Address Pool Create command creates our web server pool. Gateway name APPGW prod East US specifies which application gateway to modify. Resource group identifies the resource group containing the gateway. Name backend pool web servers creates a descriptive pool name. Use names that clearly identify the pool's purpose for easier management. Servers 10.0.2.10, 10.0.2.11, 10.0.2.12 adds 3 web servers by IP address. In production, these would be your actual web server IPs. You can add or remove servers later using the AZ Network Application Gateway Address Pool Update command. The second command creates the API server pool with different IP addresses in the .20 range. This IP organization makes network troubleshooting much easier. You immediately know .10s are web servers and .20s are API servers. The third command demonstrates FQDN usage with servers api.externalservice.com. Application Gateway will perform DNS resolution for this external service. This is useful for partner APIs or external services you don't control. The table shows the three main pool types: IP addresses for static infrastructure, FQDNS for external or cloud services, and virtual machine scale sets for auto-scaling applications. Each serves different use cases and provides different management capabilities. Health Probe Configuration Strategy. This flowchart shows my decision process for health probe configuration. Health probes are absolutely critical. They're what prevent users from being routed to failed servers. First, choose your probe type. HTTP probes are simplest for basic web servers. HTTPS probes are required if your backends use SSL. Custom path probes let you create dedicated health endpoints. Advanced matching probes can validate response content, not just status codes. After selecting the type, you set timing parameters. The interval determines how often probes run. I recommend 15 to 30 seconds. Timeout is how long to wait for a response, typically 20 to 30 seconds. The threshold is failures before marking unhealthy, usually 2 to 3 failures. The testing phase is crucial. If probes fail, the troubleshooting path guides you through checking your health endpoint, verifying network connectivity, and reviewing probe parameters. Once working, you associate the probe with HTTP settings, which then get used by routing rules. This creates the connection between your routing logic and health monitoring. Remember, good health probes don't just check if the server responds. They verify the server can actually process requests by checking database connectivity, external dependencies, and application readiness. Health probe commands detailed walkthrough. Let's examine each health probe command in detail. The first AZ Network Application Gateway Probe Create command creates a basic web server probe. The name parameter probe web health gives our probe a descriptive name. Protocol HTTP specifies HTTP probing. Host name from HTTP settings is important. It tells the probe to use the host header from the HTTP settings rather than the backend IP. This is crucial if your backend servers use virtual hosting. The path /health specifies the URL path to probe. Create a dedicated health endpoint in your application that checks database connectivity and dependencies. Interval 30, timeout 30, and threshold 3 set conservative timing. Check every 30 seconds, wait up to 30 seconds for a response, and mark unhealthy after 3 consecutive failures. The second command creates an API probe with host api.mycompany.com using a specific host header. Interval 15, timeout 20, and threshold 2 use more aggressive timing because APIs should respond quickly. Match status codes 200 to 299 accepts any 2XX status code as healthy. Some applications return 201 or 202 for health checks. The third command shows HTTPS probing with protocol HTTPS and match body healthy. This validates not just the status code but also looks for specific text in the response body, providing deeper health validation. The best practices box summarizes optimal values. 15 to 30 second intervals balance responsiveness with server load. 20 to 30 second timeouts allow for network latency. 2 to 3 failure thresholds avoid false positives, and dedicated health endpoints provide comprehensive dependency checking. HTTP settings decision process explained. This flowchart guides you through HTTP settings configuration based on your backend requirements. HTTP settings control how Application Gateway communicates with your backend servers. Getting this configuration correct is crucial for performance and functionality. The first decision is backend protocol. HTTP backends are simpler and perform better due to SSL offloading at the gateway. HTTPS backends provide end-to-end encryption but require more configuration. For HTTP backends, decide on session requirements. Stateful applications like e-commerce sites with shopping carts need cookie-based affinity to ensure users stay on the same server. Stateless applications like APIs should disable affinity for better load distribution. For HTTPS backends, Certificate validation is critical. Self-signed certificates require uploading the root certificate to Application Gateway. Public CA certificates use standard validation. You can disable validation for development, but never in production. The timeout configuration varies by backend type. Web servers typically need 30 to 45 seconds for user page loads. API servers might need 60 to 120 seconds for complex operations. Static content should have short timeouts, 15 to 30 seconds, for quick responses. Database queries might need 120 plus seconds. Finally, associate the HTTP settings with appropriate health probes to enable automatic health monitoring and failover. HTTP settings commands complete breakdown. Let me explain each HTTP settings command thoroughly. The first AZ Network Application Gateway HTTP settings create command creates settings for our web servers. Name HTTP settings web provides a descriptive name. Port 80 protocol HTTP configures HTTP communication on the standard port. Request timeout 30 sets a 30-second timeout, suitable for web page loads. Cookie-based affinity enables sticky sessions for stateful web applications. Probe web health associates our previously created health probe with these settings. This enables automatic health monitoring. The second command creates HTTPS settings for secure backend communication. Port 443 protocol HTTPS configures HTTPS on the standard secure port. Request timeout 60 allows more time for SSL handshakes and processing. Trusted root certificates backend root cert references a root certificate we uploaded for backend SSL validation. The third command shows API server settings with port 8080 for a custom port. Request timeout 120 accommodates complex API operations. Host name from backend pool uses the FQDN from the backend pool as the host header, useful when backend servers expect specific host headers. The comparison table shows optimal settings for different backend types. Web servers need moderate timeouts with session affinity. API servers need longer timeouts without affinity. Static content needs short timeouts for performance. Each configuration optimizes for the specific use case. Listener Configuration Strategy Deep Dive. Listeners are the entry points that determine how Application Gateway accepts incoming traffic. This decision flowchart shows you exactly how to choose the right listener configuration based on your specific application requirements. For single domain applications, you need one certificate and one listener, simple and straightforward. Multiple domains require separate listeners with host headers to route traffic correctly. Each domain gets its own listener and can have its own SSL certificate. Wildcard scenarios use a single listener that can handle any subdomain with one wildcard certificate, perfect for SaaS applications with customer-specific subdomains. Custom ports are needed for non-standard applications running on ports like 8080 or 8443. The protocol decision is critical. HTTP only is suitable for development or internal applications. HTTPS is required for production. Supporting both protocols typically involves creating an HTTP listener that redirects to HTTP pages. Notice how the flowchart ensures SSL certificates are configured before HTTPS listeners are created. This prevents the common error of trying to create an HTTPS listener without an available certificate. Listener creation commands explained. Let me walk through each listener creation command step by step. The first command AZ Network Application Gateway HTTP Listener creates our basic HTTP listener. The name, Listener HTTP Main, gives it a descriptive name. The frontend port, App Gateway Frontend Port, references the default port 80 that was created with our gateway. The protocol, HTTP, specifies HTTP protocol. No SSL required. The AZ Network Application Gateway Frontend Port Create command creates a new frontend port for HTTPS traffic. The name, port 443, and the port, 443, creates the standard HTTPS port. You need to create front-end ports before you can reference them in listeners. The first HTTPS listener command creates our main domain listener. The front-end port, port 443, references our newly created port. The protocol, HTTPS, enables SSL termination. The SSL cert main, references an SSL certificate we'll upload later. The host name, www.mycompany.com, makes this listener respond only to requests for this specific domain. The API listener follows the same pattern but uses the host name, api.mycompany.com, and the SSL cert API, for the API subdomain. This enables different SSL certificates for different services. The wildcard listener uses the host name's parameter with star.mycompany.com. This single listener can handle any subdomain, like app1.mycompany.com, customer1.mycompany.com, etc. The SSL cert wildcard, must be a wildcard certificate. Remember, SSL certificates must be uploaded before creating HTTPS listeners, otherwise the command will fail. Routing rules configuration strategy. This flowchart shows the complete routing rule decision process. Routing rules are where all the components we have configured come together: listeners, backend pools, and HTTP settings. Basic routing is the simplest. One listener maps directly to one backend pool using one set of HTTP settings. This works well for simple applications with straightforward requirements. Path-based routing analyzes the URL path to route different paths to different backend services. This is perfect for microservices architectures where /API/ goes to API servers, /static/ goes to CDN servers, and everything else goes to web servers. Host-based routing uses the host header to determine routing. This supports multi-tenant applications where different customers or domains are served by different backend pools. Redirect rules handle scenarios like HTTP to HTTPS redirects or domain migrations. They do not route to backend pools but instead redirect clients to different URLs. The testing phase is critical because routing rule issues can be complex to diagnose. The flowchart includes systematic troubleshooting. Check rule priority order, verify backend pool health, validate HTTP settings, and confirm listener configuration. Priority-based rules enable sophisticated scenarios where multiple rules can be associated with the same listener, with lower numbers having higher priority. This allows for a /B testing, gradual rollouts, or exception handling. Routing rules commands complete walkthrough. Let's examine each routing rule command in detail. The first AZ Network Application Gateway Rule Create command creates a basic routing rule. Name, rule web app basic, provides a descriptive name. HTTP listener HTTPS MON specifies which listener this rule applies to. Rule type, basic, indicates simple listener to backend mapping. Address pool, backend pool web servers specifies the destination backend pool. HTTP settings web, defines how to communicate with those backends. This creates a complete path from listener to backend. Path-based routing requires creating a URL path map first. The AZ Network Application Gateway URL path map create command creates the path map container. Name, path map MON names are path map. Default address pool and default HTTP settings define where requests go if they don't match any specific path rules. The AZ Network Application Gateway URL path map rule create command adds specific path rules to our map. Path map name, path map MON specifies which path map to modify. Name, path rule API, names this specific rule. Paths, API, asterisk, defines the URL pattern to match any path starting with API. The static content rule shows multiple path patterns. Paths, static, asterisk, images, asterisk, CSS, asterisk, JS, asterisk. All these patterns route to the same backend pool optimized for static content delivery. The redirect configuration uses the AZ Network Application Gateway Redirect Config Create command. Type, permanent, creates a 301 redirect that tells browsers and search engines the redirect is permanent. Target listener. Listener HTTPS MAN redirects to our HTTPS listener. Include path and include query string preserve the original URL path and parameters. The table shows the different rule types. Basic for simple scenarios, path-based for microservices, and redirect for security and migrations. The SSL/TLS configuration workflow explained. So, this comprehensive SSL/TLS workflow covers every aspect from certificate sourcing to production deployment. SSL configuration is critical for production applications, and configuring it correctly is essential for security. Certificate sources include Azure Key Vault, most secure for production, local PFX files, simplest for development, Azure Certificate Manager, for automated management, and ACME providers like Let's Encrypt, offering free certificates. Azure Key Vault requires configuring access permissions for application gateway. Local PFX files need passwords and manual management. Certificate Manager provides automated renewal. ACME providers require domain validation but offer free certificates. Your security level selection determines your SSL policy. Maximum security uses TLS 1.3 only. This provides the highest security but may have compatibility issues. Modern security supports TLS 1.2 and later. This is recommended for most applications. Compatible mode includes legacy protocols for older clients. Custom policies let you specify exact cipher suites for compliance requirements. Moving on, SSL profiles enable different security levels for different listeners. Admin interfaces might require maximum security, while public APIs use standard security policies, and legacy applications might need compatible policies. Backend SSL configuration determines whether to use SSL termination, which means you decrypt at the gateway, or end-to-end SSL, which means you maintain encryption to the backends. End-to-end requires uploading backend certificates for validation. Finally, the testing phase includes certificate validation, cipher suite compatibility, protocol version verification, and end-to-end connectivity testing. Let's walk through a detailed breakdown of each SSL implementation command. The AZ Network Application Gateway SSL Cert Create command uploads your SSL certificate. The parameter name, SSL Cert Main, creates a reference name for this certificate. Cert file, path to certificate.pfx, specifies the PFX file location. Remember to replace this with your actual file path. Cert password, your certificate password, provides the PFX password. Remember to keep this secure. The AZ Network Application Gateway SSL Policy Set command configures the SSL policy for the entire gateway. Policy type, predefined, uses a Microsoft-defined policy. Policy name, app GWSSL Policy 20,220,101. Specifies the modern policy that supports TLS 1.2 and above with strong cipher suites. This is recommended for most applications. The AZ Network Application Gateway SSL Profile Create command creates a custom SSL profile for specific listeners. Name, SSL Profile Admin Strict, names this profile. Policy type, custom, allows custom configuration. Min protocol version, TLS version 1.2, sets the minimum TLS version. Cipher suites, TLS ECDHERSA with AES 256 GCMSHA 384, specifies exact cipher suites for maximum security. The AZ Network Application Gateway Root Cert Create command uploads trusted root certificates for backend HTTPS validation. Name, backend root cert, creates a reference name, cert file. Path to backend CA certificate.cer. Uploads the root CA certificate that signed your backend certificates. The final command, AZ Network Application Gateway HTTP Listener Update, associates an SSL profile with a specific listener. SSL profile. SSL profile admin strict, applies our strict security profile to the admin listener. The SSL policy table shows the three main options. App GWSSL policy 20,220,101 for modern applications. App GWSSL policy 20,170,401S for legacy support, and custom policies for specific compliance requirements. Rewrite sets comprehensive overview. Rewrite sets provide powerful traffic manipulation capabilities. This flowchart illustrates different rewrite scenarios and when each type is typically used. URL rewrites, for example, modify request paths before they reach backend servers. This enables clean public URLs while maintaining complex backend structures. For example, you can rewrite products 123 to /legacy/product.php. It equals 123. Header rewrites can add security headers like X content type options and X frame options to all responses. They can also modify host headers for backend compatibility, or pass client information, like real IP addresses, to backends. Query string rewrites enable parameter manipulation, particularly for API versioning scenarios. You can route v1 and v2 API calls to different backends based on query parameters. Response rewrites modify outbound traffic. Examples include removing server information headers for security, or adding custom headers for client applications. Conditional rewrites apply changes only when specific conditions are met. These might include checking for specific user agents, request headers, or URL patterns. This enables sophisticated traffic manipulation based on client characteristics. The testing phase is crucial because rewrite rules can have unintended consequences. Always test thoroughly in non-production environments and validate that your rewrite logic works as expected. The troubleshooting path helps debug configuration issues by checking conditions, verifying actions, and testing rule associations. Rewrite sets implementation commands. Let me explain each rewrite command in detail. The AZ Network Application Gateway Rewrite Rule Set Create command creates a container for rewrite rules. The parameter name rewrite set URL paths gives our rewrite set a descriptive name. You can create multiple rewrite sets for different purposes and associate them with different routing rules. The AZ Network Application Gateway Rewrite Rule Create command adds a specific rewrite rule to the set. The parameter rule set name rewrite set URL paths specifies which set to add to. The parameter name rewrite clean URLs names this specific rule. The parameter sequence 100 sets the execution order. Lower numbers execute first. The AZ Network Application Gateway Rewrite Rule URL Path Set command configures the URL rewrite action. The parameter URL path /legacy/open brace path close brace uses the open brace path close brace variable to capture the original path and prepend /legacy/. So /products/123 becomes /legacy/products/123. The security headers example creates a separate rewrite set. The AZ Network Application Gateway Rewrite Rule Header Configuration Set command adds response headers. The parameters header name x-content-type-options and header value nosnif add a security header. The parameter type response header specifies this is added to responses going back to clients. The final AZ Network Application Gateway Rule Update command associates a rewrite set with a routing rule. The parameter rewrite rule set rewrite set security headers applies our security headers to all traffic processed by this rule. The Common Scenarios box shows typical uses. For example, URL rewriting for legacy backend compatibility, security headers for improved security posture, API versioning for gradual migrations, and host header modification for backend requirements. Testing and validation command explanations. Testing is where many application gateway implementations fail, so let me explain each testing command and what it tells you. The AZ Network Application Gateway Show Health command provides comprehensive health information. It returns the health status of all backend pools and individual servers, showing which servers are healthy, unhealthy, or unreachable. This is your first diagnostic tool when troubleshooting routing issues. The OpenSSLS_client command tests SSL configuration externally. The connect parameter followed by your -domain.com:443 connects to your domain on the HTTPS port. The server name parameter followed by your -domain.com enables SNI server name indication for multi-domain certificates. This command shows the complete certificate chain, supported cipher suites, and TLS version negotiated. The curl-I command tests basic HTTP connectivity and returns only headers, not the full response body. This is perfect for testing response codes and checking if your application gateway is responding correctly. The host header test with curl host:/appy.mycompany.com verifies host-based routing. You're sending a request to the application gateway IP but with a specific host header, testing if the correct backend pool receives the request. The load testing loop runs 100 requests and outputs HTTP status codes and response times. The parameter S runs silently. The parameter O followed by dev null discards response bodies. And the parameter W with the format string %brace HTTP_code brace %brace time_total brace \n outputs only status and timing. Monitor this output to see if responses are distributed across backend servers. The path-based routing tests verify that different URL paths route to appropriate backend pools. Each curl command tests a different path pattern to ensure your routing rules work correctly. The AZ Monitor Metrics List command retrieves application gateway performance metrics. Replace the resource ID with your actual gateway's resource ID. This shows response status distributions, throughput metrics, and backend response statuses over time. Production Best Practices Implementation. These production best practices come from real-world application gateway deployments. Let me explain the key configuration commands for production readiness. The AZ Monitor Diagnostic Settings Create command enables comprehensive logging. Name APPGW Diagnostics names the diagnostic configuration. The long resource parameter is your application gateway's full resource ID replace with your actual values. The logs parameter enables 3 critical log categories. Application Gateway Access Log captures all requests and responses. Application Gateway Performance Log tracks performance metrics, and Application Gateway Firewall Log records WAF events if enabled. Workspace specifies your log analytics workspace where logs are stored. This enables advanced querying, alerting, and correlation with other Azure services. The AZ Monitor Metrics Alert Create command creates performance alerts. Name app GW High Response Time names the alert. Scope specifies which application gateway to monitor. Condition a VG response time greater than 5,000 triggers when average response time exceeds 5 seconds, which is 5,000 milliseconds. Description provides context for the alert. High availability configuration requires zone redundancy, a minimum of 2 instances, aggressive health probes, and connection draining. Security best practices include WAF integration, modern TLS policies, Azure Key Vault certificate management, and restrictive NSG rules. Monitoring and alerting should include application insights for detailed telemetry, Azure Monitor for infrastructure metrics, log analytics for centralized logging, and performance metrics tracking for latency, throughput, and error rates. This comprehensive approach ensures your application gateway is production-ready with proper monitoring, alerting, and security configurations. Complete architecture achievement. Look at this complete architecture diagram. This represents everything we've built together throughout this presentation. Every component, every connection, every security layer is now configured and operational. Starting from internet users, traffic flows through our public IP to the application gateway. The WAF protection layer filters malicious requests using OWASP top 10 rules. SSL termination handles encryption and decryption, improving backend performance while maintaining security. Listener processing examines host headers and determines routing paths. Our routing rules engine applies path-based and host-based routing logic. Health check validation ensures traffic only reaches healthy backends through our custom health probes. Backend selection distributes load across our 3 pools: web servers for main application traffic, API servers for microservices, and static content servers for optimal performance. Each pool scales independently and can have different configurations. The monitoring integration shows Azure Monitor, Application Insights, and Log Analytics, providing comprehensive observability. Azure Key Vault securely manages our SSL certificates. Health probes continuously monitor backend availability. This architecture provides multi-layered security, intelligent routing, high availability through zone redundancy, auto-scaling from 2 to 10 instances, comprehensive monitoring, and modern TLS security policies. You've successfully built an enterprise-grade application delivery solution that can handle production workloads with confidence. Congratulations on your journey forward. Congratulations! You've completed this comprehensive Azure Application Gateway configuration journey. Look at everything you've accomplished. From basic infrastructure setup to a production-ready deployment with enterprise-grade monitoring and security. You built robust infrastructure with zone-redundant application gateway and autoscaling capabilities that can handle traffic spikes automatically. You implemented intelligent routing with both path-based and host-based routing for complex application architectures. Your health probes ensure high availability by continuously monitoring backend health and automatically removing failed servers. You configured enterprise security with SSL/TLS termination using modern cipher suites and security policies. Your rewrite rules enable sophisticated URL manipulation and header modification for enhanced functionality. You established comprehensive logging and alerting for operational excellence and proactive monitoring. Your next steps include deploying Web Application Firewall for OWASP Top 10 protection, implementing infrastructure as code with ARM templates or Terraform for repeatable deployments, setting up CI/CD pipelines for automated configuration updates, configuring custom error pages for better user experience, implementing application insights for detailed performance monitoring, and exploring Azure Front Door for global load balancing. Remember, these skills you've developed will serve you well in building robust, scalable, and secure application delivery solutions. Keep practicing, keep learning, and keep building amazing things with Azure. Thank you for joining me on this journey. You're now ready to deploy and manage Application Gateway in production environments with confidence.